Hello, everyone. Right. Um, Thank you for attending my talk. And I'm Saurabh Arora, and I'll be talking about building performant and secure server-driven user interfaces. Okay, that's really a mouthful. I probably myself didn't realize that. But okay, first, a few things about me. I'm a senior Android engineer, and I've been working and building Android apps for close to about 6 years now. Outside of work and meetups, you would see me watching and playing tennis. Recently, I've been a lot into fitness as well, and I'm learning calisthenics. So do send me a message if you're into fitness, tennis, or calisthenics as well. I would really love to have a chat with you, probably get to know some of you better. And lastly, I work at Rakuten Wiki. For those who don't really know, Rakuten Wiki is actually an OTT platform specializing in Asian content. We license primetime Asian TV and movies and bring them to rest of the world. And our biggest USP is that our content that we are trying to bring to the rest of the world is actually subtitled in over, I would say, in about close to 100 plus languages by a community of really passionate volunteers who subtitle these shows for us. Our engineering office is actually based in Singapore. And that's where I'm dialing in from. I'm originally from India, but currently based off in Singapore. And it's about 1 a.m. right now in Singapore. So I hope I still do sound a bit energetic and not sleepy and tired given the time. And I hope I'll try my best not to uh, come across as being sleepy or forget something in the middle. Okay. So Wiki, like a lot of content listing apps that you might be familiar with, such as e-commerce apps and other OTT services or food delivery services, we all have this notion of, server-driven interfaces where the app bundles a predefined set of layout widgets and they can appear anywhere inside our entire app or mostly on the home feed, as we call it. And these set of widgets or this layout, there's no fixed ordering to them. And the approach is slightly different than apps which are built with configurable, with having a static layout in mind. So this is more like a platform really tells us, or a backend really tells us where to place these widgets and what kind of content to show in them. And such kind of configurability has made it a lot easier for our product team to run A/B tests, for our marketing team to, strike deals and license and partnerships with a lot of other providers, and accordingly highlight them or feature them higher in the order in our home feed. So when we were building this, like roughly about a year and a half ago, even though a lot of apps have this done, I realized there isn't much information available outside on how is the best way to approach this. So through this talk, I'll try to share some of the challenges we encountered when we were trying to build something like this, what lessons we learned, and if you or somebody else has to begin such a project or endeavor in the future, I hope there'll be some takeaways from this talk which you could put into your future use. So first up, let's look at how we can surface this layouting information to the end app. So so here's a sample of the wiki app we have, and as you can see, we have a banner at the top, and we have a rows of list, and then we have another thing that we call a billboard. Now, this is just example positioning. These positioning can change. So one way to do this is you have an API which will actually send you the layout info along with the contents for each row. So in this example, as you can see, I have a layout type which is saying, hey, render a banner. And I'm also giving you the data that is to be shown inside that banner. Similarly for recommendations. And even though this API looks the easiest to use and it seems like, hey, it's the best. I just call one API, I get the entire content, I know what to do, and I just render it. When we started off with this, we realized that quickly this started to run into scalability issues with our backend team, right? The issue we had with this is, for example, let's say you have user specific content in the response, like here you have recommendations. This means that the response coming in from the backend is actually cannot be cached because each API response is now being tailored to individual users, which means it cannot be cached by intermediate proxies and ISPs. So this will increase server load and costs as well. Even your local, let's say, disk cache or OKHTTP network cache will not cache this response because every time you want to refresh, the recommendations might have changed. So building it inside one API had this downside. Another downside, which we quickly realized, is that if this one big API is down, the app will not load at all, and not even in a degraded mode. Like, let's say certain sections are down, we would want to surface other kind of information. Stuff like this would still not work because we have one giant API. This would make for a terrible user experience for the end user. So how can we do better? Like the next idea we had, like, let's split this API into actually two APIs. One is your content API, and the other, sorry, one is your layout API, while the other is your content API, the one which serves information about the content for each row, right? And this we quickly realized would a solve our cache issues. Like if we know that certain API responses can be cached, the content ones, we don't need to worry anything about them. The platform can keep on working and be like, hey, tell the intermediate proxies to cache this content for about 30 minutes. And there's no issues at all because the content API is separated. And we don't even need to signal an error on the homepage because if a single layout row is down, like that corresponding API is down, you just drop it from the feed rather than, signal an error for the entire page, right? So from this layout API, as I mentioned, it will just have layout information and it will contain API information for what should be called for each row. So here I have an example where we are showing that we have a path, we have the params, and we have the type of API call to make in order to get information about what should be shown in this row. Now, again, even though this was the first draft that we came up with it, and it looks sufficient for clients, we realized that this made the app susceptible to man-in-the-middle attacks. And by man-in-the-middle attack, I don't mean like somebody would be able to sniff your API response. We all have SSL pinning these days. We're communicating over HTTPS, so not those kind of man-in-the-middle, but even since our app supports older API versions, even pre 6.0, there are still ways in the Android system to actually be able to see the API call that's being made by by users being able to install certificates in their app. So what we wanted to avoid is somebody, let's say, for example, changing the type to a delete and then change the API endpoint, and our app would just call some API and delete something on our backend, which would cause havoc. We really didn't want something like this. Also, so for that, we actually went ahead and removed the type from this schema we had. We assumed that everybody will only make a get call. Next up, the issue we spot is that we are actually sending the entire API path. Now, the issue with sending this entire API path, which we also quickly realized, was that somebody could go ahead, swap it with some other endpoint, right? And if they were smart enough to match your API response with the response your app was expecting, you would actually go ahead and display somebody else's content in your app, and that could again be a disaster. So a quick fix for this was also to remove API path that comes in. And what we would do is you would only make sure that you're sending the path that's to be called, nothing about the host or the domain name. That becomes a responsibility of every client to append, even though it's a bit tedious and a bit more extra effort on each client to parse and then prepend the domain name. This does make your implementation a lot more secure. And the added functionality being, if you're a client and you have, like most apps have staging server and a development server configuration in them, by not having your path being a part of your layout API, this allowed us to quickly switch between these two domains. Okay. And this was a similar concept we actually adopted for deep links as well. The idea being the same, that if we put in the host for the deep link, there could be a possibility that we navigated the user to some potentially harmful websites or somewhere else where we shouldn't have really taken the user. By making sure there's no host name, it guaranteed us that the deep link that would be set by our product or our marketing team would actually keep the user inside our app. And if that deep link was something which had a domain name in it, we would just simply ignore it. Okay, so now I first ran through what a layout config file could look like for an implementation similar to ours, and how to make sure that you're not putting in any information inside that which would allow any malicious third party to actually redirect your app or show content which does not belong to you. So now let's look at the Android side of things and what are the learnings we had when we were actually implementing this on our Android app. So first thing to consider is when we are fetching the layout config. And the first point I would like to make is have a reasonable default. This config that we talked about earlier is important, but not a critical component for the app to start. If you're not able to fetch this, your app should probably still function. So bundle in a reasonable default layout config, which you will use when you're unable to fetch this config from your API or from a third-party A/B testing tool, right? But one thing to note with this default config is that since it's a JSON and for an app like an OTT service or an e-commerce app, you would notice there are like 20, 25 of rows. So if you bundle this default config as a string, there'll be huge memory implications for this. So therefore, instead of defining your default as a string, what we realized is what helped us with memory consumption is that we moved this default actually to a JSON file, and only if we fail to get the response from the server, we would actually return a blank. And if the response was a blank, we would then open the file, read from it, and then return that as a response. This helped us save a huge chunk of string allocations that were happening in our app at app launch when we made the first few releases. Okay, next up, I would also like to recommend that you think about backwards compatibility. When you begin development or when is the first time your product or your design team approaches you with building something like this, you'll realize that let's say they only define 5 layout types. And in the future, they might want to add a couple of more, and you wouldn't want older apps to crash or misbehave simply because now you're sending a new layout type which the older app did not understand. One way to do this is use enums to store the type of layouts that you support. And along with that, add another enum called, let's say, unsupported. And so if you receive a layout type that you don't really recognize, mark that as unsupported. And then you can choose to either drop this unsupported layout type or render it using some default state that would be your own product or business decision. Okay, so now we've looked at the fetching the layout config. Now let's look at how would we design such a view or such an experience for the user. So for our UI, we actually tried out two POCs. First, we tried out a linear layout based implementation, and next we tried out a nested recycler based view based implementation. For a linear layout based implementation, what we did was that we made each row as a child. Each row was a child view or a fragment, if you would like. And each of this view was fully responsible for making the API call, rendering itself or hiding itself in case of a failure. The recycler view based approach was actually a lot more challenging because now there's one giant list in which you need to keep on making sure that you have to remove items from the list when the response doesn't come in. You also have to make sure that the the ordering is correct. So it was a lot more challenging to build, but it was a lot memory efficient because you could make sure that the views which are below the fold, recycler view doesn't really render them. So that was a big memory win for us. So we went ahead and we actually started using a nested recycler view. So for the next part of the talk, I'll actually look into the challenges we faced with this, with the nested recycler view approach, and not talk about the vertical linear layout based approach, which we actually discarded. So the first issue we faced with the recycler based approach was actually with layout row ordering. And what I mean by layout row ordering is, as soon as we receive a response from the layout config, we would iterate over it and fire out all the API calls that were needed for all rows. And the thing with API calls is there's no guarantee that they would come back in the order in which they were fired. So if we fired API call 1, 2, 3, 4, 5, the fourth API call might come first, followed by the second, and then the first. So we need to make sure that even though the API calls came out of order, the way the data was displayed was actually in order of the layout row. And because you had separated your layout row from the main data API and not have one giant API, you would also want to make sure that you lazily render. Like whenever the content comes in, start displaying it rather than to wait for all, let's say 25 rows have 25 API calls, to wait for all 25 API calls to actually finish before you start displaying anything to the user. So for this, what we did is before we fire an API call, we set up empty placeholder rows. Now these represent all the 25, like for example, all the 25 rows of content that the corresponding API calls are being made. And when each API response returns, we actually replace the placeholder row in the list with the actual content, and we use diffutil to update the UI. To avoid frequent calls to diffutil, we can actually collect and batch updates that are being made, since the API responses are very likely to come back uh, during the same time frame, mostly in fast internet connections. But for smaller internet connectivity, there is a possibility that they come staggered. So for them, we batch the updates every 200 milliseconds, and that gave us a good user experience and a good way to show content as it came in. Okay, next up, let's look at how we reduce inflation time and scrolling jank by actually using recycled view pools. So for here, when the user actually swipes sidewise, the inner recycler views that we have here, they recycle the view and give you a smooth scroll. But that's not the case when you actually scroll vertically. Each of the views of the inner recycler view, when you're scrolling vertically, will actually be inflated again. And this is because the nested recycler view, each of the inner recycler views maintain its own view pool. So using a recycle view pool, that allows you to share views between multiple recycler views. And so to share view pools, as I mentioned, what you could do is you could create a new recycler view pool and assign it a view type. Now this view type should actually be the same as the view type which is defined in your adapter. So for that, a simple trick that we use is your get item view type, make it the same as your layout resource ID. So when you're inflating, you actually just simply inflate whatever is returned by the view type, and that matches what you mentioned inside your view pool. So at this point, I personally actually thought that was it, because when I was going through the recycler view documentation, they only talk about recycle view pools and how to set them. But this didn't actually work for us. What I realized is you also need to configure the layout manager to support view pools. The linear layout manager, for the example that we are using, it has a flag which is recycle children on detach. This flag make sure that the layout manager will recycle its children when it's detached from the recycler view. So whenever you're using view pools, just remember to set this as true. Once we had this set up, we actually wanted to measure if this really made any kind of difference in the inflations that we were actually encountering in our app. So to do that, what we did is we created an atomic integer and we just incremented it every time your on create view holder method was being called. And for the benchmark that we ran, we saw that we did 24 rows. We had 14 rows and each row had 24 items in them. And from our test, we realized that without sharing a view pool, we actually had 83 inflations. And with sharing view pools across the inner recycler views, our layout inflations had actually reduced by 1/3. Okay, so that was view pools and using them to reduce view inflations. Next up, let's look at how we save horizontal scroll positions. Okay, so you- as we scroll vertically in a nested recycler view, the horizontal scroll position, like I've tried to demo it here in the GIF here, the horizontal scroll position would actually be reset when the row comes back into view. And that's because that row was detached and recycled, and then the adapter was bound again for the inner recycle view. So it actually lost the position where the user was when the user scrolled away from it. And that was not a pleasant user experience. So from what here we realized is the layout manager is actually responsible for positioning the items inside the view. and hence it has information about the scroll position. And it exposes an on save state and an on restore instance state method. So I felt like we thought we could actually, if there's a way we could get that information in, like the state of the layout manager, save that somewhere, and when this adapter is being bound again, we actually restore the state of the layout manager. To build something like this, we were actually inspired by the safe state registry, which is a part of the Jetpack components. For anyone who is not familiar, safe states registry is a part of the, like it's an interface for plugging components that consumes and contributes to safe state. It is tied to the lifecycle of the owning component, generally the activity or the fragment, which means that when an activity or the fragment is being restored, your anything which is implements the safe state registry interface will also get a chance to restore a state itself. So we were inspired by this, but we couldn't use this directly because a recycler view is not a lifecycle owner for us. So we did our own custom implementation, which I'll quickly run through it here. What we did is we created a recycler view state class, which would actually define a state owner. And the state owner interface will be the one which would expose a function to get the state of the recycler view or the layout manager, and a way to restore that state into the recycler manager, and also a key. The key will be actually used to add and retrieve the state from the bundle, which will hold the states of all the rows inside the nested recycler view. Next up, the class also provides a way to start the save state process, simply because, as I mentioned, this recycler view is not a lifecycle owner, so there's no way to say, hey, there's no way for the system to come in and say, now is the time to save state and now is the time to restore state. So we provided hooks to trigger this manually ourselves. And similarly, we have a restore state method. And note that the restore state is only doing when there's some kind of data found for the key. We simply don't want to reset the layout manager to to a clean state, because when the first time it's created, it's obviously going to be in the clean state. Okay, so now let's look at how we get the recycler view to actually use this framework that we created. What we have the row list view holder, actually, like our inner recycler view, actually implement the state owner. And the get state and the restore state methods simply return and restore the state of the layout manager. And the key for this example, we can assume it's the title of the row. So each row has its own different title, so the key will be unique per row. This key will now be used to identify the state bundle for this row specifically. Now when the data is actually, now when the inner recycler views data is actually being bound to the adapter, you can actually kick off the state restoration process, which would then call the layout manager and tell it to restore state with the bundle information that was stored in the recycler in our state registry. And for the first time bind, there's actually no state restoration to take place, simply because nothing was saved earlier. Correspondingly, to save the state, that became the job of the outer adapter of the vertical recycler view. The recycler view has this on view attached to window and view detached to window. These were the two methods that we latched on to actually being able to save the state. So on detached window is actually called when the view is no longer visible to the user. So at that point, we can rest assured that the user, would not be scrolling left and right on the view. So it's a perfect time for us to actually of save the state and the positioning of the inner recycler view. But here, we felt we could further optimize this, simply because right now we are saving state of all the rows that are there, irrespective of the fact that did the user scroll on this row or not. So for that, we can create a scroll listener. Inside the scroll listener, we will make sure that we will first mark this content as dirty. So as soon as the user scroll, you can actually you will say, hey, this the layout manager of this row is now dirty. So I would need to save state for only the rows which are marked as dirty. And for good measure, we also trigger the save state process when the user scroll action has now been settled. So what this gives us is only when the user scrolls left and right on the row, only then will the row's state will be saved. Otherwise, we would not run through the save state process, and neither do we run through the restore state process. Okay, and now that we have our state restoration working on the recycler view, we can see how as we scroll left and right, and then we scroll up and down, the row for the wiki picks in the example here actually maintains its state position. Okay, so now another issue that we ran into with nested recycler view was view snapping. And what I mean by view snapping is, the default recycler view does not snap. And if you see in the example here, what happens is if you swipe left and right, the content of the row doesn't really align to the start of the list. What happens is it just stops right in the middle, which doesn't give a pleasant user experience. So the good thing is RecyclerView comes with a snap helper that helps us snap items out of the box. The default implementation does center snapping, but you can actually customize it to perform start-based snapping as by just implementing your own snap helper. I'm not going to get into the details for this, but once you have this, you can actually see what I mean by having snapping capability. So here, as we swipe left and right, and we let the recycler view settle into idle state, it will snap itself to the nearest item to make sure that it's fully visible instead of being partially visible. Okay, and finally, let's look at how we address this the issue with the scrolling behavior that we have. So as you can see in this video, like if you try to scroll a nested recycler view while the parent is still settling the scroll, you can't do this easily. This is an issue which is quite common with nested recycler view, and the Android implementation of the nested recycler view doesn't really handle this out of the box. So to do this, we needed to actually extend the inbuilt recycler view and override the on intercept touch event method. So when the user moves his finger, we actually check if the scroll direction matches the recycler view direction. If it does, we intercept the touch event. Otherwise, we actually don't. So this implementation actually helped us fix the scroll behavior where while you're scrolling left and right, you're still able to just continue scrolling up and bottom without any issues. All right, and with that said, that's it for my talk. I think I missed the conclusion slide, but okay. Yeah, that's about it. Thank you so much for listening in and tuning in. Yeah, time for any Q&As. Okay, I have a question. What were some of the Android tools you used to profile memory usage? For this, we actually use the inbuilt memory profiler and the CPU profiler to see what kind of memory consumption we were having with our implementation that we have with both linear layout and recycler view layout. So that served us really well for figuring out how often were our layouts being inflated. As I mentioned in the slide presentation earlier, what worked for us better was actually simply just logging out the number of times the view holder was actually being inflated rather than relying on the memory profiler to tell us. That did work, but it was just easier and faster for us to just simply log. Okay, another question is found any performance issues while scrolling vertically after you save state for some rows? We actually did find a bunch of performance issues, which is why we did the further optimization that we only will save state for rows that were actually scrolled by the user and not just simply save state when the user is just scrolling up and down instead of scrolling left and right. So what this helped us is with that if you do a fast scroll, none of the rows that we crossed over would actually need to save state because the user never really scrolled left or right on them. So that was one of the findings which we had, which really helped us reduce the jank we saw when we were scrolling up and down in our app. How do you, okay, the next question is from Raul, which is about, or Raul, sorry if I pronounce your name wrong. How do you make sure server and UI syncing and making perfectly fine? Actually, how do you make integration tests for them? So for this, what we did is first up, we actually made sure that we were backwards compliant by having an unsupported type of layout row so we could quickly just drop whenever the server was not in sync with what the front end or the clients were showing. Secondly, for integration tests, we actually spinned up a so what we do at Wiki right now currently is we maintain a separate repository with all a set of mocks which every client actually uses, and we set up a local by using mock web server. We set up local tests to make sure all the data, all kind of layout combinations are actually being tested using unit tests and in certain cases espresso tests as well to make sure that there are no syncing issues. What really worked best for us has always been to be a bit more defensive in our app, whereby we will drop anything, any kind of configuration that we don't support. And that configuration has not just been in terms of just layout rows. What we've also done is in terms of platform API response, if we get a response type that we don't really understand, we just simply just drop it rather than try to make sense of it or fail at the time of trying to render it on the screen. Simply, we've also seemed to have struggled with making sure your backend and your client are always in sync. So being a bit more defensive and supporting backwards compatibility has helped us alleviate this concern quite often. I might have missed this part. Okay, another question. I might have missed this part, but if you made 1, 2, 4, 5 requests, do you just wait for all the requests to complete or do you show the rows and rearrange after? Actually, so when we make all the API requests, we don't really wait for all these requests to complete. What we do is once we first have our layout configuration, we would render all of those rows, but with empty data. So it's just placeholder content that we put on the screen. And as soon as the API requests come in, simply because when you have the layout row, you can use some ID to tag your API request that went out. So when the response comes in, you look at the ID and replace the item in your list, which only had placeholder dummy data. You swap them out and replace them in with the new data that has come in, and just send it over to diffutil, which will process everything and let you know that only this content for this row has changed. So you don't need to rearrange anything later. It's just the placeholder data goes away and the actual data comes in, while the other rows still continue to show the placeholder dummy data. Okay, next up is, did you have concerns when making this possible? Would it be easier with Jetpack Compose? Actually, to be honest, yes. We are trying internally right now to actually see how we can implement this with Jetpack Compose. It's still a work in progress. I don't know how easier or difficult it would be. Early thoughts are it does seem a lot more easier, but we actually started this process a year ago, where Compose was not even announced. I believe like before we when we started doing this, we the Android framework team hadn't really announced anything about Compose. So using the current set of tools was our only option that we had. But I do feel like our initial internal prototypes are definitely showing that with Compose, this becomes really a lot more easier, and we don't really need to deal with a lot of state restoration and the snapping issues that maybe the snapping issues we've not got there yet, but definitely not the state restoration issues. They didn't know that when you used vertical linear layout, doesn't the off-screen view get reattached? That is interesting. So for a vertical linear layout, it will actually render all the content in one go. Linear layout does not really have, let's say, a recycling process whereby it adds or removes children based on this based on the information that based on the display area, and it wouldn't really remove the items that are below the fold. That's not really how linear layout works. Linear layout is just one big canvas on which all of your child views are inflated and inserted, irrespective of the fact that whether they will be displayed in the current viewport or not. So that for us was a big hit in terms of performance. Okay, all right then. Yeah, that's it. Rest. I look forward to the talk on the platform. If I look forward to the questions on the platform in case there are any other. Thank you so much for your time and thank you for tuning in.